In our last class, we discussed about compound angles, these are compound angles, double angles, triple angles, half angle, product to sum formula, sum to product formula. But the thing is, go back to the video, the last part, cos A minus cos B. I wrote cos here instead of sine. Please note that error. So we have sine, we are having sine cos. Sine, we are having sine cos. Cos, we are having cos. If it's minus, it will be sine. So note the pattern. So this is summary of what we did last class. And it will be nice if you can notice, if you can put this at the back of your mind. So mainly today we want to solve questions using these identities or these formulas. Example 1, we have to evaluate the following. So the first one is for us to get sine 195 without the use of calculator. But the thing is, first, whenever you see any angle that is more than acute, any angle greater than 90 degrees, we can always put them to the first quadrant. So this is an angle in third quadrant because second quadrant is less than 180. This is more than 180. So any angle we have in the third quadrant can be written in second quadrant by what? By removing 180 degrees from it. Recall, angle in the first quadrant can be expressed as angle in third quadrant minus 180 degrees. So meaning we can write this one as this theta 3. So we want to get as theta 1. So if we remove 180 from this, we are going to get what? 15 degrees. But the thing is, at the third quadrant, what happened? Cast 4, 1, 2, 3. At the top tan is what? Positive. So it means sine will be negative. So it means sine 195 will be equivalent to what? Minus sine 15. So we use quadrant to reduce the third angle to first quadrant angle. Then next question, we have to use compound angle. What can we combine to get 15? What special angle can we combine to get 15? Recall special angles are 0, 90, 60, 30 and 45. So we want to select two angles here to subtract to get 15. So there are two things you can do. It's either we remove 45 from 60 or 30 from 45. 45 minus 30 will give us 15. 60 minus 45 will give us what? So let's use 45 minus 30. So it means this same thing as writing. You can say write as minus sine. What is 15? 45 degrees minus 30 degrees. What next? A minus B. What is sine A minus B? That's sine A cos B minus sine B cos A. So this is what sine, these are A, cos, these are B. If you have minus here, we are going to have minus here. Minus, then we'll swap the angle, sine 30 cos 45 degrees. Now let's impute the special angle. Sine 45 is root 2 over 2. Cos 30 is root 3 over 2. Minus sine 30 is half. Cos 45 is root 2 over 2. So what happens? So from here this is written as negative root 2 times root 3 over 4 minus root 2 over 4. So what happened here? Root 2 over 4 is gone. Let's bring it out. This becomes minus root 2 over 4. Then here we left it root 3 minus 1. Or final answer, we can just write it as minus root 2 root 3 minus 1 everything over 4. So that's the final answer in third form. That is for sine 195. So note this down and let's move to the next one, tan 105. 105 is an angle in second quadrant. What do you do? Angle in second quadrant can be expressed as 180 minus angle in first quadrant. So we'll do 180 minus 105. So if you do 180 minus 105, we are going to get 75. So this is tan 75. What happened? At the second quadrant, only sign is positive, so this will be negative. So the first is to turn the angle to first quadrant. So two special angles that can be summed to 75 are 30 and 45. So this is written as minus tan 30 degree plus 45 degrees. So this is tan A plus B. So what's tan A plus B? So if we have plus here, we have a plus up and minus down. So this is negative, you can bring negative out. Tan A 30 plus tan B 45 divided by 1. If we have plus up, we have minus down. Minus, now multiply tan 30, then tan 45. What next? We can now impute the values. So tan 30 is 1 over 3 plus, what is tan 45? 1. This for numerator. Divided by the denominator, we have 1 minus. Tan 30 is 1 over 3 multiplied by 1. Because tan 45 is 1, so it changes nothing. So this becomes negative. This one, that will be 1 plus root 3 divided by root 3. Sorry. Divided by root 3 minus 1 over root 3. So what left? This 1 plus root 3 over root 3 times root 3 over root 3 minus 1. So what happens? This takes this out. So we are left with negative 1 plus root 3 over root 3 minus 1. We can also write it as root 3 plus 1 also, instead of 1 plus 1. So this is our answer, but in mathematics, we don't allow a rational number at the denominator. So what are we going to do? We are going to rationalize. Multiply by root 3 plus 1 over root 3 plus 1. So at the end of the day, we'll be having negative. So when this multiply this, we'll be having root 3 plus 1 all squared divided by applying difference of 2 squared. This will be 3 minus 1, and that's 2 as our final answer. Note, this square is not affecting this negative. In fact, let's finish it up. So this minus, if you expand this, you'll be having 3 plus 1, that will be 4 plus 2 root 3 over 2. 2 is common, so 2 can cancel 4 and 2. So the final answer is negative 2 plus root 3. That's this final answer. The last one cos 345. 345 obviously is an angle in fourth quadrant. So what do we do for angle in fourth quadrant? We remove the angle from 360. So 360 minus 345 is 15. So this is equivalent to cos 15. And in fourth quadrant, what happened? Cos 4, 1, 2, 3. In fourth quadrant, cos is positive. So this remains positive, not negative. What can we combine to get 15? Let's use 60 minus 45. Then we are going to be using the identity for cos A minus B. If you have minus here, you'll be having plus here. So that will be cos 60, cos 45, plus, if there is minus here, we use plus sin 60, sin 45, like this. Now, let's impute the special angles. Cos 60 is 1 over 2, cos 45 is root 2 over 2, sin 60 is root 3 over 2, and sin 45 is root 2 over 2. So from here, something is common. This is root 2 over 4 plus root 3 times root 2 over 4. So if we factorize root 2 over 4, we let it 1 plus root 3. So the final is written as root 2 multiplies 1 plus root 3 all over 4. That's the answer for cos 3, 4, 5 in short form. Let's take example 2. Write the following as a product of 2-3 ratio. This is sum to product. Sum to products. That is why this formula they are important. This is sum to products. You have to commit them to memory. Or if you are very fast improving, look for a way to always find out. So here, sin, and we have plus. Sin, you have plus. So first, if it's a theory question, write out the formula before you apply. So because the formula is already on the board, we apply straight. So you're applying the first line. So we'll do 2 sine. A plus B means we add this to angle. A is 8x, B is 16x. That's what? 8x plus 6x over 2. Then cos A minus B. What is A? 8x minus 6x over 2. As simple as that, if you can record the formula. So 8 plus 6 is 14 over 2, that is 7x. Cos 8 minus 6 is 2x over 2, that is x. So the answer is what? 2 sine 7x cos x. It looks simple if you can recall the formula. Next one is sine, we are having minus. Sine, we are having minus. So we apply the second formula. That will be 2 sine A minus B. That's 12x minus 4x. 12x minus 4x over 2. Then we have what? Cos. We now add. That will be 12x plus 4x over 2. So this becomes 2 sine 12 minus 4 is 8 over 2, that's 4x. Then for this one, 12 plus 4 is 16 over 2, that's 8. That's cos 8x. As simple as that if you know the formula by heart. The next one is cos with addition. Cos with addition. So we add the two angles, then we subtract using cos each. So what are we going to have here? 40 plus 2 is 16 over 2, that's 8. So that's 2 cos 8x. 40 minus 2 is 12 over 2, 6, that's cos 6x. As simple as that. The next one, cos with negative, that's the last formula. So that will be 2 sine, we add the angle, sine, we subtract the angle. What next? 4x plus 6x is 10x, that's 2 sine, 10 over 2, 5x. 4x minus 6x is minus 2 over 2, that's minus sine x. Sorry, that's sine negative x. So and this negative can come out because sine minus x minus sine x. So we can stop here or we can write the answer as minus 2 sine 5x sine x. And that's it. So we apply this to solve the question example 1, this for example 2. So example 3, we have to show the following. We have to show that cos 2a minus 1 over cos 2a plus 1 is this and this also. Let's start from the first one. Let's start from the right hand side, left hand side, and show it to the right hand side. Now, if you observe, we have double angle here, we have A, we have 2A here. So the first is to try to express this 2A as A. And what are you going to use to come back here? Cos 2A is what? Cos 2A is 2 cos square A minus 1. This is cos 2a. Then we have another minus 1 here. Over cos 2a here is 2 cos square A minus 1. This is for cos 2a. Then we have plus 1. So what happens at the numerator? We are having 2 cos square A minus 1 is minus 2. Divided by minus 1 plus 1 cancels, so we left it what? 2 cos square A. And this because 2 is common at the numerator, that's cos square A minus 1 over 2 cos square A. 2 cancels 2, so this becomes cos square A minus 1 over cos square A. And recall, what is cos square A minus 1? Sin square A plus cos square A is 1. So cos square A minus 1 is what? Sin square A. So this is sin square A over cos square A. Square is common, that's sin. Straightforward, sin over cos is tan with the square. That is tan square A, which is what? The right hand side. So the left hand side equals to the right hand side. Or a rat, demonstrando. Done. For the second one, let's start from the left hand side also. Same thing. You're having A, 2A. So you have to place double angle with single angle. What's sine 2A? Sine 2A is what? 2 sine A cos A divided by 1 plus, what is cos 2A? Cos 2A is, let's use in terms of sign, of course, anyhow. But I think I would love to use the one in terms of sign. So that let's use 1 minus 2 sine square A. If you don't like use the cos, get the same thing at the end of the day. Just the one will be longer than the other. 2 sine A cos A over 1 plus 1 is 2. That's 2 minus 2 sine square A. And this becomes 2 sine A cos A over 2 is common here. 1 minus sine square A. These two cancels these two. So here we're having sine A cos A. Then 1 minus sine square A is what? Cos square A. Which I can write as cos A cos A. Cos A cancel cos A. What is sine over cos A? That's tan A, which equals to our right hand side. So left hand side equals to right hand side. Quadrat what? Yes, demonstrandum. Now look at the third one. Okay, let's start on left hand side as usual. Cos 2A. What is cos 2A? Should we use this or this? Now, in this case, we have to manipulate. In fact, it might be better you start from the right hand side. But let's still continue with our left hand side. So, you either use cos or sine, but I'll use sine. And I'll tell you the reason why later. 1 minus 2 sine square A. Why am I using sine? Because I know that I want to get tan at the end of the day. And how do we get tan? Tan is sine over cos. Now, question involving fraction, I told you earlier on, we can use difference of 2 squared. But now, this one doesn't have fraction, we want to include fraction. So we can also rationalize in other manner. What's contrary of this one? That will be 1 plus 2 sine square A over 1 plus 2 sine square A. I don't know where this will take me, but let's see. So from here, cos 2A becomes, the one we have here, we multiply. Should we expand? Let's say write it as 1 minus 2 sine square A, 1 plus 2 sine square A, divided by 1 plus 2 sine square A. It doesn't look like what we want. Nah, this doesn't look good. Although this and this has a connection, plus plus, this and this minus minus, but doesn't look good yet. Let's look at it together. Let me think. Do you know what? I think let's start from the primitive method, cos 2A. So let's use cos A plus B. Let's start from scratch. So what is cos A plus B? Cos A plus B is cos A cos B. We have plus B using minus there. Minus sine A sine B. So what will now be cos A plus A? Meaning we replace B with A. That will be cos A minus sine A sine A. A plus A is 2A. That's cos 2A equals to cos square A minus sine square A. Don't mind me. So this is the step before the final answer here. So what am I going to do next? If you notice, if I divide some by cos, I'll be having 1 sine over cos will be tan. So let's divide both sides by cos square A over cos square A. This becomes cos 2A over cos square A equals to, it will split. This will give me 1. Sine over cos give me what? Tan square A. Then I can bring this one here. So it means cos 2A equals to 1 minus tan square A times cosec square A. Sorry, times cos A. But what next? What can I do here? Recall that sec A is 1 over cos A. So for me it means cos A is 1 over sec A. So I can say from here cos 2A equals to 1 minus tan square A. This becomes what? 1 over sec square A. So it means from here cos 2A equals to 1 minus tan square A over sec square A. What does sec square A recall? that 1 plus tan square A is sec square A, part of the identity. So from here, it means cos 2A equals to 1 minus tan square A over 1 plus tan square A. So left hand side equals to right hand side, called erat demonstrandum. Manipulation. We've used this, and this. We only use this. Most of the Joe asks you to look for it, this. So meaning we only need to solve question with these two. For example 4, we are told to solve these two equations. Let's start with the first one. When you look at this equation very well, you see that this is 3x, this is 2x, triple angle, double angle. So that's why you need to know the two identity. So what I meant to do, we are meant to slot in the value. What is cos 3x? Cos 3a. That's cos a, so I'll write cos x. Into bracket, 4 cos square a, 4 cos square x, minus 3. That is for cos 3x. Then minus 3, what is cos 2x? Cos 2x is, that's cos 2a. 2 cos square a, in this case cos square x, then minus 1, that's for cos 2x. Then we have another what? Cos x outside. Then outside we have another cos x. Let's expand and see what we are going to get. 2 times 2, we have 8. Cos x times cos square x, that will be cos cube x. Minus 3 times 2, 6 cos x. Let's continue here. We have minus 6 cos square x plus 3. Oh, we still have another cos x outside. So the expansion of this gives this. So we have to expand this cos x. This cos x multiply this one, this will turn to cube. Then it will multiply this 3, that will be 3 cos x. So this is the full expansion for this. Then we have plus cos x equals to 0. Let's collect like terms. 8 minus 6, because they are both cos cube, that was 2 cos cube x. Then do we have square? I think there's no square. Now, since there's no square, then let's combine this. Minus 6 cos x plus 3 cos x is what? Minus 3 cos x plus 1, that's minus 2 cos x equals to 0. So what can we do here? 2 cos x is common. If you bring out 2 cos x, you will let it what? Cos square x minus 1 equals to 0. Yes, bring out 2 and cos x. So from here, this is what? 2 cos x multiply by what? Everything here can be written as difference of 2 squared. Cos x plus 1, cos x minus 1 equals to 0. So what happened? We equate each into 0. So from here, it's cos x equals to 0, or cos x plus 1 equals to 0, or cos x minus 1 equals to 0. From here, 0 over 2 is 0, so it means cos x equals to 0, or cos x equals to minus 1, or cos x equals to 1. So cos what will give us 0? Cos 90 will give us 0. So from here, our x is 90. So for this one, cos what will give us 1? Cos 0 will give us 1. Sorry, but what about minus 1? Let's draw the cos graph here. So here, cos is 0 here. Cos is also 0 here. So this is 90, 180, 270. So 90 and 270 will give us 0. Or minus 1. The only thing that will give us minus 1 is this, 180. So 180 will give us minus 1. What will give us 1? This will give us 1. 0 will give us 1. And 360 also give us 1. So 0 degree, 360 degree. So these are the values of x that satisfy this particular equation. Let's do the second one. We have to solve sine 2x equals to cos 3x. Double angle, sorry, sine 3x also. Double angle, triple angle. So what are you going to do? What is sine 2x? Sine 2a. Sine 2a is 2 sine theta cos theta. That's 2 sine x cos x. What about sine 3x? Is here. That's sine a, that's sine x. Open bracket, 3 minus 4. 4 what? Sine square A. In this case, sine square x. So what happened here? Can we cancel sine x? Since it is an equation, let us cancel. Let's bring this one here. Because for some value of x, sine x can be 0, this can be 0. And 0 over 0 is not allowed in mathematics. So after bringing this one in, what do you notice? Sine x is common. So let's factorize sine x. What we left here? 2 cos x. Then we have minus left. Multiplying 3 minus 4 sine square x equals to 0. So from here we have sine x into 2 cos x minus 3 plus 4 sine square x equals to 0. Here we are having both cos and sine together. So what can we do? Let's raise sine with cos, because sine square x is 1 minus cos square x. So this is sine x into 2 cos x minus 3 plus 4 into 1 minus cos square x. So that will be left only cos in the bracket. So here we have sine x into 2 cos x minus 3 plus 4 minus 4 cos square x equals to 0. So minus 3 plus 4 is 1. So what can we do? We can actually take it from here. Minus 3 plus 4 is 1 plus 2 cos x minus 4 cos square x. Then let's equate both to 0. So it means sine x is 0, sine x is 0, or 1 plus 2 cos x minus 4 cos square x is also 0. Or we can multiply, we can bring everything to the other side, or multiply it by minus 1. So this becomes 4 cos square x minus this. So we can write this one as 4 cos square x minus 2 cos x minus 1 equals to 0. And this is what? A quadratic equation. For this one, the solution is easy. So sine what will equal 0? If you check your sine graph, so sine 0 equals 0, and sine what? 180 with sine 360. So for this particular one, 0, 180, 360 satisfies this equation. While for the next one, we are first going to look for the value of x by solving this quadratic equation. We can let cos x, let cos x be p. So this becomes 4p squared minus 2p minus 1 is 0. Then we'll solve this quadratically. After solving it, we get two values of p. After doing that, we recall there and we'll solve. We've solved something similar in trig 2. I believe we can finish it off from here. So finish this. Then the last question. Now look at this last question. Express 2 cos 3x cos 2x as a sum of 2 cosines. So cos as a sum of 2 cosine. This product to sum. And is it product cos to what? Cos. So you have to use this formula straight. Then hence or otherwise obtain an expression for cos 5x. Cos 5x in terms of cos x. One of the importance of this product to sum is for us to be able to do multiple angles. You know, this is double angle, triple angle. What we have to do cos sine sheet. Sine 4a or cos 4a or tan 4a or even 6a. That is the importance of this. Now following this formula, cos a cos b equals to half into cos a minus b plus cos a plus b. Since on the question there is 2 here, so let's bring this 2 here, multiply 2 by 2. Then this formula turns to this. Then what next? Let's write this below it. We have 2 cos 3x cos 2x. This means a is 3x, b is 2x. A is 3x, b is 2x, plus a is 3x, b is 2x. So it means 2 cos 3x cos 2x equals to cos, what do you have here? Cos x plus cos 5x. We've obtained an expression. We've expressed this as a sum of 2 cosines. And it's also useful in integration, in case you are taught to integrate this. So it's easier for us to split it this way before integrating. We are done with the first part of the question, as simple as that. Now obtain an expression for cos 5x. What is that? Is here already. Just make this cos 5x the subject. So from here we can say cos 5x equals to, bring this one to the side. That's 2 cos 3x cos 2x minus cos x. But that says in terms of cos x only. So we replace cos 3x and cos 2x with the identity for triple angle and double angle. So this becomes 2. What is cos 3x? That's it there. So that's cos a outside, that will be cos x, multiplying 4 cos square x minus 3. We'll close this for cos 3x. We still have cos 2x outside. What is now cos 2x? Cos 2x is here, cos 2a. That's 2 cos square x. 2 cos square x, then minus 1. Then outside we have minus cos x. We are done. You can expand and finish it yourself. But let's go on with it together. So that's equals to, let's leave this 2 outside, this big bracket. So let's expand this first. This multiply this, we are having 4 cos cube x minus 3 cos x, multiplying what? 2 cos square x minus 1 minus cos x. Let's continue expanding. Let's leave this 2 here. Let's open the bigger bracket. This will give me 8 cos 5x, or is it cos 5x or cos raised to power 5x? This and this. Then this will give me minus 4 cos cube x. This will give me minus 6 cos cube x. This and this will give me plus 3. Then minus cos x outside. Have I made a mistake? I'm not sure. Let's continue. So this 2 into this and this, they are like terms. Minus 4 minus 6 should give me minus 10. Is it going to be minus? Let's check again. This with this and this minus. Okay, that's minus 10 cos cube x plus 3 minus cos x. Expand. So it means we have what? 16 cos power of 5 of x minus 20 cos cube x plus 6. But write this one first, minus cos x. Then this one plus 6. So this is the expression for cos 5x in terms of that. So from here it implies that cos 5x equals to 16 cos power of 5 of x minus 20 cos cube x minus cos x plus 6. Final answer. Fifth angle. And this is the end of trig for O level. Any other trig is for advanced level. So stop here. See you in my advanced class.